Hello friends, and welcome to the module 1 of our chapter. So the first thing you must keep in mind is what is an angle is. Now we all know what is an angle, so I've learned about since we were small about it, but in a simple definition I give in textbook, the amount of rotation from the initial side to the terminal side is called the measure of the angle. So you know what an angle is. If you have any two rays like this way, they join together and they form an angle over here. That's an angle. Anything is an angle. For example, if I have two pens over here and join them together in two different points and they form an angle. So you basically know what the angle is because I'm talking about it since so long time. But there is one more thing to talk about in angle. It's about positive angle, negative angle. Now what this means. And I hope you know what is clockwise and anti-clockwise means. If you don't know, let's look at the watch, which I have with me here. In this watch, if you observe the direction of the needle, you find it's moving in this direction. Can you see it clearly? Yes, you can see it. So this will be called as the clockwise direction, moving in this format. You can see it clearly, yeah? Clockwise direction. And the reverse of it is called anti-clockwise. It's very important to first of all know what is clockwise and anti-clockwise, because you can talk about not only in this chapter but any of the physics, maybe mathematics, or even chemistry, or in general life itself. You must know what is clockwise and what is anti-clockwise. Great then. So whenever you find an angle is moving in the anti-clockwise direction, it is said to be a positive angle, and the vice versa should be a negative angle. So let's understand in more detail. Find. So let's say I have my pencil kept at this position and moving it in this anti-clockwise direction like this way. So in such case, the angle formed will be called a positive angle, moving from right to the left position. Isn't it? Yes. Similarly, if I have the same initial side and I'm moving this time not in anti-clockwise but in clockwise direction, like this way I'm moving it, and that will be called as a negative angle. So I hope you understand what it means. Positive and negative is very simple to understand. Now moving on to talking about measurement of angles. So don't you worry, all of this notes will be posted on one of our website. If you want to know, just comment below so I can just quickly send it to your mail or whatever you want in. Let's move on. Talking about measurement of angles. So there are different or many ways of measuring angle, but for our concern, based on this chapter, you need to know two very important things: degree measure and radian measure. Now you know degree measure, what it means, yeah? I'm talking about in our different contents so far. So we see this in this protractor. You have dimension different degrees. This is called a degree. You barely know what is degree is. But there's something more you must know about degree, that is 1 degree is equal to 60 minutes. You may be wondering, how is it possible? How is it even possible? But don't you worry, there's something which you must keep in mind, because these things are related to our physics topic also. You can see in other chapters. But here let's understand that this one means minute and this double quotation means second. So 1 degree is 60 minutes and 1 minute is 60 seconds. So simple as that, yes. And that's it. You know what's right angle, you know what's straight angle, all the things you already know. So for now you have to keep in mind is under degree measure you have two more new things, that is 1 degree is 60 minutes and 1 minute is 60 seconds. Now why do we need this? For some conversion work, we can see soon. Talking about radian measure. Now what do you mean by radian measure? If it's the first time you have heard this name, I'm going to tell you exactly what it means. So let's see a circle. Circle is given to you. It has radius, it has arc also. The definition says a radian is an angle suspended at the center of a circle by an arc whose length is equal to the radius of the circle. Now what this means? It means that you have a circle with you. It has a center O, let's say radius R, as you can see. Now this is forming an angle at the center. Let's say this angle theta. And this angle theta is in such a way that the arc which is having it over here, this length is equal to radius. That is, this length L, let's say, is equal to the length of the radius. So this both are equal, which means all of this part are equal. If so happens, then the angle form is called radian angle. And in this case it is 1 radian. Simple as that. So what you have in a radian is that you have a radian is basically an angle. Understand, like how you have degree is an angle. So it's an angle formed in a case where the length of the arc is equal to the radius. Simple as that. Now when do we need this? We need for different format. We'll talk about unit circle soon. So for those who are going to talk about this also. So in our textbook, we have talked about this so far. Moving on to our degree measure, we have covered all this part so far. And they're given a small, very important relation, that is theta is equal to L by R and L is equal to R theta. But they have explained exactly how it is so. So I'm going to tell you how it is this, how it's been derived, and how to remember the formula as whole. Just understand them. Here they have given, in a circle of radius r, if an arc of length L suspends an angle theta at the center, then theta is equal to L by r. Now what this basically means is that, let's consider a circle with center O, as you can see, and radius r, as you can clearly see here. Now let angle AOB is equal to theta. So this angle, let it be theta, as you can imagine it to be. And let arc AB be L. Now we need to prove what? We need to prove that theta is equal to L by R. This is what we need to prove. This is kind of a formula which we need to learn. But let's see how we can prove this thing up. Because it's important to understand the proof, even though they won't ask it, to be able to understand the concept well. Moving on, so let C be a point here on AB such that AC is equal to R, which means this is nothing but our 1 radian, because if all of them are equal, it forms 1 radian. So 1 radian. It is represented by small c at top. If you have not seen my paper carefully, I'll mention it over here, that radian is shown by c, a small c at top. Okay, fine then. Moving on. So then angle AOC will be equal to 1 radian. We know that the angles at the center of a circle are proportional to the length of the arc suspending. This is simple kind of a, you can say a property or a kind of a theorem which you have. So we can have angle AOB divided by angle AOC is equal to arc AB divided by arc AC is equal to L by R. So in that case, we have proved that theta is equal to L by R. You can see it, isn't it? Yes, because arc AOC is nothing but 1. So theta by 1 is nothing but theta, giving L by R. So that's the formula. You can see how the proof is got. But now the question is how to remember it. It's very simple. I have taken a small trick to remember it. Take it as or. You know the word or. Or means or this or that, like that way. So we can remember as or. So or is equal to L. Now what this means is or can be taken as O as theta. So theta into R is equal to L. That is same lesson. L is equal to R into theta, or theta is equal to L by R. So very simple way of remembering. So we get confused about what is where. You just remember it as or is equal to L. So where that or O is nothing but theta. So theta is equal to L by R. The formula is very simple. It's important for me to remember because from here maybe 1 marks or 2 marks question might come in exam. Moving on to the next important thing, that is relation between radiant and real numbers. Now all the things I've talked so far are just the introduction part. So you don't have to, like, sit down here and just learn this by heart. No. Just understand them. That's it. Let's have a look at next concept. Let's see it up. Relation between radiant and real number. Now what they basically want to convey through this whole diagram, and if we read it once, you can understand very simple. What they want to basically convey is that if you take a circle over here, okay, I'm taking a very simple circle and having a radius OA, okay, and like that way. Now let me take a tangent. Let me draw a tangent to this given circle like this way, in such a way that I take this as point A, contact with the line, and the point P and Q. I mean like the line P and Q. And let us have in the direction of PA, let me have positive numbers like 0, 1, 2, and similarly on AQ let me have negative numbers like 0, -1, and -2, and so on. So if I wrap up this thing on this one like this way, like this part is there, I'm wrapping on of this, and like this is there, I'm wrapping on of this. It's basically gonna form the corresponding direction or the circumference of the circle, isn't it? Yes. So from this we can say that the radian measure and the real numbers can be considered as one and the same. Now why do we need to learn this? If we are able to understand that radian measure and real numbers are the same thing, then it will be easier for us to understand the domain and the range of the trigonometric function. That's it. Okay, that's it so far. Now next comes the important conversion. We must know relation between degree and radian. Now what is it? Okay, this part is understand it and just learn the formula. That's it. That is, we have over here that 2 2 pi is equal to 60 degree and pi is equal to 180 degree. The conversion says radian measure if you want to convert from degree to radian. So first case when you convert from degree to radian, the formula is radian measure is equal to pi by 180 into degree measure. And if you want to convert from radian to degree, that's the opposite way. It's going to be equal to 180 by pi into radian measure. It's a very simple thing, isn't it? Yes. And when talking about radian, we normally don't write down the C on top. We just write it as it is. But because we know it's basically radian. Okay, that's it. So learn this two important conversion, that is radian or degree to radian and degree to radian and radian to degree. Next, we have a very small thing to note in mind. Now we know 30, 45 degrees, 60 degrees and so on, but how to know the same thing in radian? That is very important also, because sometimes we use the radian value and not degrees value. So 30 degrees is called pi by 6 in radian, 45 is pi by 4. Now how to remember the sequence? It's very simple actually. The 45 would be pi by 4, so you know 4 is there, so it means 45 degree. That we can remember it. For 60 and 30, we can see a bit kind of a common sense or change in it. When in 30 degree it is pi by 6, it's pi by 6, and for 60 degree it is pi by 3, so you can see how it is, and that we can remember it. For 90 is pi by 2, you have to remember it as it is, and 180 you already know it is pi, and 270 is 3 pi by 2, and this is 2 pi. So remember this thing. So far which I have learned so far in this content, to be able to solve exercise 3.1 perfectly and clearly, the first thing you must keep in mind is this conversion part, that is this two part. Let me put a small star. That's it. And second thing you must note down or remember is this this formula, that is theta is equal to L by R, the second formula. And third thing you must note down is this two conversion formula, how to convert it. And lastly, if you want to be more advanced and more ahead of your content, also know relation between them, these two things. This much is enough for you for this portion of the content. And after that you have examples, as you can see here. So now you're going to go through all the examples and see how to be solved and how to understand them well. So let's get started. Before we move on, note a very small thing about converting from degree to radian and radian to degree. Converting from degree to radian, first have a check if the question is given in proper degree or not. In proper degree means is given, let's say something like 25 degree or not, in a proper degree form. If it is yes, then I directly use the formula and convert it, which I have learned. And second, if it's given, let's say in less 25 degree, 37 minutes and 36 seconds, you can see there is also this part. It's not in a proper degree form. In such case, convert into proper degree form by dividing by 60 and then use the formula. Okay, that's for degree to radian. What about radian to degree? For that one, first step, directly use the formula and convert it as it is, and then you're going to get the answer. Now check the answer. If the answer is in proper natural number, as you're going to see in this example here, natural number, proper natural number, then leave it as it is. But if you find it to be in a improper form or might be in improper fraction form, as you're gonna see like it was here for like this part, it's in improper form. In such case, then convert into mixed form like this way, and then go on multiplying by 60 to simplify it into minutes and seconds. And if it's still improper, as you can see in some example, then just write nearly. So you can see over here how we have derived the answer, and this is how you normally do it. So now you understand more clearly as I'm gonna show you how to solve it. But for now, just keep this point in mind and note it down. So example 1 says, convert 40 degree and 20 minutes into radian measure. So you know what this single quotation means. It means minutes, and double means seconds. Yeah, keep that in mind. So as per, you know, the first thing is check if it's in proper degree or not. It is not, so first convert to proper degree. Now how to do it? Divide by 60, as you can see here. 40 plus 20 by 60 degree divided by 60, giving you this one. Make it LCM, you get 121 by 3 degree. Now convert it into radian form, because now it's in proper degree form. Yeah, everything's in degree form. I convert into radian, because pi by 180 into 121 by 3, because the formula is this, pi by 180 into degree measure. So it's convert like that way, and you can keep the pi as it is. No need to solve for this one, and that's the answer. The second question says converting 6 radian into degree measure. 6 radian means 6 small c at top. Now to convert this, we're gonna have to do is into this one. Now for this thing, now we're converting from degree to radian. No need to change, no need to put the value for pi, but then converting from radian to degree, you have to put a value for pi because we're gonna be wanting the degree to be in a proper form. Yeah, so pi is 22/7. Never ever use the decimal form, use the fraction form. Talking about this part, I mean in this section, in conversion section. And doing on, I have got it to be in this form. Now this is not in a proper form, it's in improper form, so I'm dividing it to give a mixed fraction that I have got 343 degree plus 7/11 degree multiplied 6/16 to become into minutes, which I have again got into improper form, and doing it further and further I have got it into this much form. Now at the end, as you can see, even after doing into second, I'm still getting another remaining answer, so I'm going to put it as nearly, so you can see is how we do it. Very simple. Okay, let's go through step one more time. Now you'll be wondering why am I solving it. Actually, for this kind of simple question, I'm showing the solution of how to do it, but for some very difficult question, I'm going to show you step by step how to solve it with my writing, okay? Because you have more problems to be done, so you don't have much time, so let's go move on. And let's do it. It's very simple actually. I have understood the flow. So there's one more very important question over here which normally comes in the exam. That is for, let me show you. It is for -4. When you have -4, 4. For this question, -4, that's converting to a degree. This is a very important, this normally comes in exams. I'm going to show you for this question how to do it after some time. Now third example says, to find the radius of the circle in which the center angle is 60 degrees, intercept an arc of length this much. To visualize this question, I can take a circle here, as you can see here. A circle has been taken. Let's draw it over here itself. Circle is taken. It is forming an angle 60 degrees like this way. The arc length is 37.4 centimeter, and find the radius of it. Now you know the angle is always in radians. I first convert the angle was given in degree to radian. So you know 60 degrees is nothing but pi/3. So it's going to be pi/3, isn't it? And the formula is theta is equal to L/R. So R is going to be equal to L/theta, which is going to be equal to 37.4 divided by pi/3. And on doing so, step by step, I'm just going to put in the value and just go on solving it. And now you can see how I've done here. Very simple, putting in the value and getting the answer. Okay, fine then. Now the fourth question is quite tricky. So far the question we write is the application, very simple question, but the fourth one is a bit tricky because I've given about minute hand and how it works. Let's have a look at it. The fourth question comes here. The question says, the minute hand of a watch is 1.5 centimeter long. That varies to 5.5 centimeter long. How far does a stiff move in 40 minutes? Now what this means? So let's write down what they've given to us. They've given us radius as 1.5 centimeter, and you know 2 pi is 60 degrees, and we now need to find out the length of the arc, isn't it? So that's going to be L is equal to R into theta. Now we know the R to find out theta now. So talking about the minute hand, as you can see in my watch, when it takes one whole circle like this, it means 60 minutes, and it's taking 360 degrees. So which means a minute hand makes one revolution in 60 minutes. So degree completed in 1 minute will be 360 by 60 to give it 6 degrees. In completed 40 minutes will be into 40 to give it to 40 degrees. So hope you understood how it's been done. So it's very simple. Understand the logic first of all. So you're having a clock with you, and you know that when you take one whole revolution, what happens? Two things happen. So first thing, it is covering 60 minutes, giving you 1 hour. And second thing, it is covering 360 degrees, isn't it? Yes. So dividing them up, you get 6 degrees in 1 minute into 40, give it 240 for 40 minutes, and convert that into radian measure because you need to find L. And putting the value, you can get the answer easily. Great, yeah. Moving on to now fifth example question, which says, if the arcs of the same length in two circles. Now among here we discussed so far, I feel this is one of those questions which is very common in exam, because the minute hand they really give, because you know it's kind of a confusing type, but this question they give it because here we're talking about relation also. about the ratio relation. Okay, the question is if the arc of the same length in two circles subtend angles 65 degree and 110 degree. Now if you have a doubt in the meaning of the word suspend, what it means, suspend normally comes with along with circle. That is, if we have a circle, suspend means form an angle at the center of the circle. This is called suspend. An angle 65 degree and 110 degree at the center, and to find the ratio of their radii. Let's see how to solve. Now here they have given, there are two circles and they both have different radius, they have different theta, the angle, but they have the same arc length. So it's the advantage of the length on and find out the answer. So let R1 R2 be the radii of the two circles. Given that the theta 1 is 65 degrees, we can convert it easily into our radian form, as you can see here. And they have given us length of each of them is equal, so you can just convert them as like this way, they both are equal. And write down the answer like this way, cancel the common part, and with that way you can find out the ratio. Very simple. Yes, hope you understood how the flow goes. Everything is clear? Not clear? Let's look at how it's been done. We know what is theta 1, we know what is theta 2. Write down the value, convert it into radian form with in degree form. Then it's a formula that L is equal to R into theta. Because it comes the formula that theta is equal to L by R, just replace this one this side, you get the formula as it is. Let's put in the values, let's go and cancel the common on both the sides, and you get the answer it. Very simple, yes. Now comes exercise 3.1. Exercise 3.1, the first question is to find the radian measure corresponding to the following degree measure. So convert from degree to radian. You know the rule, first check if it's in a proper degree or not. If it is not, then convert into proper degree and then use the formula to convert it to radian form. The first one is 25, a very simple one, so use the formula and find the answer. Second one is minus 47 degree and 30 minutes. You have minus. Now don't get confused or get, think it's very simple actually. Just take out the minus outside of the whole thing and just write down the other thing inside and just go on solving it within. So here what you have to do is divide by 60 to convert it into degree form, giving you half over here, and you have got this as it is, and it is basically 47 to 1 by 2, and you know how to convert this mixed fraction into improper. Do 2 into 47, 2 into 47 plus 1, and you get the answer to be as this one. Now this one with the minus is converted into radian measure, and that is going to be your answer. 240 is also very simple, just use the formula and get the answer. Okay, next we have is our 520, which is also very simple actually. The same way you have done 240, just similarly you multiply by pi by 180 using the formula, and you're going to get a very simple answer to it. As you can see for this one, radian measure into 180 and convert it up, so you can give very proper answer for this also. This one, yep. Okay, there you go. Moving on. Second question says to find out the degree measure from radian measure. The first 11 by 16, you can see is how simply have done here. So into the formula and go on doing the division of it. Now, this is a very simple question, so I was showing how the solution has been done, but for the next question as minus 4 degree, I mean for radian, I'm going to show you exactly how to solve it step by step. So you can see how it's been done. Just cancel out it. I hope you know how to cancel it. And then you're going to get an improper fraction, as you can see here. Convert to mixed fraction because you want it in minutes and seconds. So for that, you have to just multiply by 60 in each of them, and go further doing it until you get degree, minute, and second. If you get more further, then just make it nearly. But for now, we have got a proper answer. But let's see for minus 4 radian, how to do for this. So minus 4 radian converting to degree measure is going to give me degree measure is equal to minus 4 into 180 by pi. As I've told you, have to use the pi as the fraction form, so I hope you remember it. Okay, so let's see. Minus 4 into 180 into 7 by 22. This is going to be minus 2, 11, giving us minus 14 into 180 divided by 11. So 18 into 14 is how much? 2, 3, gives me 7, 8, 1, giving you 251, so 25 minus 2520 divided by 11. This is an improper form. Let's convert into mixed form. It's in degree, remember it, degree. Okay, fine. So it's going to be 11 divided by 2520. 11 2s are 22. 22 minus gives me 3 2. Again 2s are because 3 is a 32 is 1 less, so 22. It's going to give me 22, so minus 10. Again 0 comes down here, so 0 is there. So now I can do it to be as 9s are 99 minus 1. Simple, yes, okay. So giving us, so this is our answer, 2 to 9 degree plus 1 by 11 degree. Now convert into more simpler form, 2 to 9 degree plus 1 into 60 into 11. That is going to be our minutes, yeah? This is going to be 11 divided by 60 is how much? 5s are 55 divided by, gives again 5, as you can see here, giving us 2 to 9 degree, okay, plus, so how much? 5 minutes plus 5 by 11 minute, which is going to be again into, I'm going to do 60 to give us 7 seconds, isn't it? That is 300, isn't it? Because 300, so it's going to be 300 again. 300 divided by 11 to give me how much? 2 is 22 divided by 22 gives you 80. 7s are 77. Again 3 comes down. Now this is giving me 2 to 9 degree plus 5 minutes plus 27 seconds plus 3 by 11 second more. Now again further is too much because I have got all the 3 components. I'm gonna make it as 2 to 9 degree 5 minute 27 second and nearly. So hope you understood how to solve it in very simple terms, and that's how you get the answer for it. Moving on to the next question now. 5 pi by 3 is very simple actually. It's just very simple method to solve it, as you can see here. Just use the formula and find the answer. 7 pi by 6 is also very simple. I have solved it over here. Let me just show you. Directly use the formula as you can see here and just solve it up. Now the remaining 3rd, 4th, 5th, 6th and 7th question, let's see how to solve it there. The 3rd question says a wheel makes 36 revolutions in 1 minute. Through how many radian does it turn in 1 second? This has very simple logic here now. It is saying that it has a wheel and is making 36 revolutions in 1 minute. Now what it means? It means the number of revolution in 1 minute is 36 seconds. So number of revolution in 60 seconds would be 360. Also, so in 1 second would be 6, yeah? So which means it is making 6 revolutions in 1 second. And in a way the circular thing's gonna produce 360 degree per 1 revolution. So 6 revolution means 6 into 360 degree. So which means convert it into radian measure is what they want us to do. So using that formula, get 12 pi. So hope you've understood how it's been done, because the question is simply asking us to tell us how many radian it is making in 1 second. So we're just converting it into simple terms and find out the answer. That's it. The next question says to find the degree measure of the angle suspended at the center of a circle of radius 100 cm by an arc of length 22 cm. Okay, so given us over here what? They have given us the length and the radius. Find out the theta value. You have got it to be 1150 and convert this into degree measure. That's it. Simple question, simple application and simple doing of it. Great. Next question says in a circle of diameter 40 centimeter, the length of a chord is 20 centimeter. To find out the length of a minor arc of the chord. Now this might be same out of the box question, but it's very simple actually. Visualize the circle now. Let's take a circle. And this specific circle is having our diameter 40 centimeter. True? Yes. It also has a chord of 20 centimeter. A chord is here, this is over here, of 20 centimeter. Okay. Now, if the diameter is 40 centimeter, the radius will be 20 centimeter because half of it. So it's going to be, let's draw a radius over here like this way. which is 2020, you can find out that all this has 20 centimeters, which means this angle is going to be 60 degree. Why? Because it is nothing but our equilateral triangle. And now this thing to find out the minor arc of the chord length. So find out the length of this chord. Very simple, convert this degree into radian, use the formula and find out the answer. But let's see how I have done it. It's a very simple question, as you can understand. The solution is as here. As you can see here, very simple, diameter is given, radius is given to us. Let's see, TV the chord, 20 centimeters, all sides equal, because it's equal to triangle. And just find the formula and find the answer. Okay. But here they have not converted the pi, so just leave it as it is because it isn't radian measure. Fine. Lastly, talking about the sixth question, which is similar to the question I've done an example, which says, in there are two circles given to us which have the same length of the arc, but they have suspend two angles, as you can see here, and find the ratio of the radii. The same way how I solved the example, let the two radius be r1, r2, and convert the theta or the angles into radian measure for both of them, and apply this concept and find out the answer, find the ratio. Okay. Lastly, but not important, but let's go through it. The question says to find out the angle in radian through which a pendulum swings if its length is 75 centimeter, and the tip describes an arc of length this much. Now, what this means, just in simple terms, is that they have given us the radius, as you can see, 75 centimeter, and they have given the different arc length at a different time, as I find the angle to it, I mean the theta. Very simple, yes. Now our next concept, so I have understood clearly the whole concept. Now a quick review we have done so far about angles, talked about the degree measure, radian measure, its important formula, which I've seen in the application also, is relation between radian and the real numbers, which are not applied yet, but you have seen degree and radian conversion, important part over here, seen all the problems, everything you have seen, everything done completely in exercise 3.1. Fantastic. Now is our trigonometric function, another important part here. Now so far exercise 3.1, these are just the basic thing, which the instruction to make you feel very light and okay. From here onwards, the main important content, the main important things of the chapter starts. And even these are very simple actually, not very complex, but let's see what we do next. In the next class, I'm going to talk about trigonometric function in detailed manner. What is it? What is the function? Then have a look at all of this important things to keep in mind about this unit circle and how is radian used in our application of the function. It's important trigonometric ratios which I have learned, but we have more to be learned about. And then we have the general solution formula, introduction to it. Then sign of trigonometric function is a very important part. Talk about some rules to discuss, some things of it, and some problems to go through, some some small formulas type of it, and domain and the range of trigonometric function, a very interesting part too. And becomes examples. The examples are given to us here. All the examples is given to us. Then the exercise. So I hope so far what I've taught you is very clearly, you have understood it well, you have understood the content well and how to solve the problem, and I feel very good that even the video is quite long, but I guess I was able to rightly introduce to you the chapter, rightly able to describe every part of the CBSE textbook till so far, and similarly I'm going to do for other content also. So for now, stay tuned and don't forget to like, subscribe, comment, and also give me any emails if you want to, if you want more solution, if you want these notes, of course, if you want the notes and all those things, because I have done this for all of you so you can learn well and of course master your CBSE textbook. Thank you and have a wonderful day.